wondered how a company founded in 1993 to improve video game graphics turned into a titan of 21st century AI.
We need artificial intelligence to help us explore the universe in places that we could have never done ourselves.
Nvidia has just dropped a bombshell in the tech world with their latest AI chip that surprised the whole industry. This new technology not only pushes limits, but seems to rewrite the rules of physics. What this means for the future of artificial intelligence is still a debate among the tech giants. How will this chilling discovery change our understanding of technology? Let us explore Nvidia's astonishing new AI chip and why it could destroy humanity. The rise of Nvidia in the AI boom. Once known primarily for improving video game graphics, Nvidia, a California company, has grown remarkably to join the elite group of companies valued over $2 trillion. This exclusive club includes tech giants such as Microsoft, Apple, and Alphabet, Google's parent company. Nvidia's dramatic rise from $1 trillion to $2 trillion in just 8 months is driven by the intense demand for its advanced technology that is central to the current boom in artificial intelligence. In March 2022, Nvidia launched the Hopper architecture, which was specifically designed to enhance AI accelerators used in data centers. This release set off a wave of excitement within the AI sector, significantly boosting the demand for these products. Throughout 2023, a period marked by an AI craze, the demand for Nvidia's products reached new heights. This led to long wait times, with customers waiting anywhere from 36 to 52 weeks to receive their H100-based servers after placing their orders. Impressively, in just the third quarter of 2023, Nvidia managed to sell an extraordinary 500,000 units of the Hopper-based H100 accelerators. Nvidia's dominance in the AI market with its Hopper products was a crucial factor in its substantial increase in market capitalization. Moving beyond the Hopper, Nvidia introduced the Blackwell architecture, named after David Blackwell, an esteemed American mathematician whose work in game theory, probability theory, information theory, and statistics significantly influences current AI model design and training algorithms. In October 2023, during an investor presentation, Nvidia unveiled the latest updates in its data center technology roadmap, introducing the B100 and B40 accelerators that incorporate the new Blackwell architecture. The transition from what was previously hinted at as Hopper Next to Blackwell was officially announced at the Graphics Technology Conference on March 18, 2024. The event, held at San Jose's Pro Hockey Arena, attracted over 11,000 attendees, including software developers, technology leaders, and happy investors, all keen to see the latest from Nvidia. At the conference, Nvidia's CEO, Jensen Huang, emphasized that Blackwell represents more than just a chip. It is a comprehensive platform that goes beyond typical GPU production. With an architecture that integrates 2 dies into a single unit, Blackwell operates with unparalleled speed and efficiency, boasting an impressive communication speed of 10 terabytes per second and functioning without any memory or cache difficulties. Despite skepticism regarding the ambitious aims of Blackwell, Nvidia pressed ahead and achieved significant breakthroughs with this innovative chip. Blackwell is designed to integrate seamlessly with Hopper, facilitating straightforward upgrades while also demonstrating its formidable capabilities through a prototype board. This setup includes a pair of Blackwell chips and 4 Blackwell dies connected to a Grace CPU with ultra-fast links, marking a significant advance in computing capabilities. In addition to these advancements, Nvidia introduced a novel feature in its 5th-generation NVLink within the new Transformer engine. This innovation doubles the speed of its predecessor, the Hopper, and includes computation capabilities within the network itself. This is a crucial development because it allows multiple GPUs to efficiently share and synchronize information, significantly enhancing overall performance. Despite its rated speed of 1.8 terabytes per second, the actual performance of this new setup exceeds expectations, offering substantially greater speed than the Hopper. The new format, known as FP6, enhances training performance by 2.5 times per chip, and the introduction of FP4 doubles the throughput for inference tasks. These improvements are vital for energy conservation, reducing network bandwidth, and optimizing time usage, which are all essential for the future of generative AI technology. Nvidia has named this time generative AI because it marks a major shift in computing technology. At the core of this shift is Nvidia's newly designed processor, made specifically for this era, featuring a technology called FP4 format that aids in generating content tokens. This processor is a part of the Nvidia Blackwell AI supercomputer and boasts a capability 5 times greater than its forerunner, Hopper. Yet, Nvidia appears ever eager to push beyond its current achievements, already planning to develop a bigger and more powerful GPU that surpasses the present model's capabilities. The NVLink switch, Nvidia's latest invention, holds 50 billion transistors, almost equal to the entire Hopper chip. This chip is designed with 4 NVLinks, each capable of transferring data at 1.8 terabytes per second, allowing all GPUs to operate at maximum capacity simultaneously. This represents a significant leap forward in computing, offering a glimpse of a future where such powerful systems are the norm. The evolution from the first DGX model to the latest one is a tale of exponential growth and ambition. The initial DGX-1 model started modestly with 170 teraflops of computing power. Now, Nvidia projects its latest models to achieve 720 petaflops, edging closer to achieving 1 exaflop of processing power within a single machine. A milestone in computing power that stands as a testament to Nvidia's relentless pursuit of advancement. This single machine, compact yet immensely powerful, is capable of operations that were previously thought to be possible only with multiple machines. The DGX series is not just another powerful AI system, it is a pioneering effort to achieve exaflop processing in a compact form. Such a system is rare, with only a few existing globally, making the DGX a standout in the world of high-performance computing. The architecture enabling such formidable computing power is Nvidia's NVLink spine, which astonishingly supports a bandwidth of 130 terabytes per second. This bandwidth capacity surpasses the total capacity of the internet, demonstrating the sheer scale of data that this system can handle. This capability is achieved without the need for high-cost optical components, which not only reduces the system's overall cost, but also significantly lowers its power consumption by saving up to 20 kilowatts in a setup that requires 120 kilowatts in total. The cooling system employed is equally impressive, using a liquid cooling method that keeps the system operating at a cool 25 degrees Celsius, despite the immense heat generated during operations, ensuring optimal performance at all times. As Nvidia's success grows, we explore the story behind their powerful chips, discover how their new designs change the world of artificial intelligence, how Nvidia's GPUs transform AI. At the heart of Nvidia's system is the GPU, which is far from simple in its construction or function. Today's GPUs are marvels of engineering, comprising over 600,000 parts and weighing about 3,000 pounds each, roughly the weight of a large automobile. These GPUs are crucial for managing and executing complex computational tasks, such as training advanced AI models with trillions of parameters. Previously, such tasks would require several months and an enormous amount of electrical power. With the Hopper architecture, this time was reduced to 90 days using 8,000 GPUs. However, with the introduction of Blackwell, the efficiency has increased dramatically, accomplishing the same task with just 2,000 GPUs and significantly less power, only 4 megawatts. This marks a monumental leap in both efficiency and performance, highlighting Nvidia's commitment to not just improving, but revolutionizing the field of AI computing. As Nvidia prepares for what may be its most successful product launch yet, the company is also venturing into a new territory, Nvidia Robotics. This new domain extends beyond the digital confines of data processing and AI models running on systems like the DGX. Nvidia is now exploring the physical interaction of AI with the real world, a step into a realm where machines are not just processors of information, but active participants in the physical world. This initiative could transform how robots interact with their environments, making them capable of independent decision-making and interaction. This isn't just a technological advancement. It's a groundbreaking shift towards integrating AI more deeply and effectively into everyday life, offering a glimpse into a future where AI could interact with the physical world as naturally as it does with data. Nvidia has been diligently developing a comprehensive system for robotics, including their AI powerhouse DGX, designed for training complex models, and AGX, the first robotics processor of its kind, built to handle high-speed sensor data in environments that require low energy use. Nvidia's bridge between the digital and physical realms is Omniverse, a sophisticated virtual simulation platform housed on the Azure cloud. This platform enables a fully automated warehouse environment where humans and machines, like forklifts, work together efficiently. The system, acting like a sophisticated traffic director, ensures safety by managing the movement of both humans and machines in the warehouse. Remarkably, this system operates without delay, allowing for real-time interactions with the intelligent warehouse, and each robot in this setup operates independently, enhancing overall efficiency. Nvidia's technology isn't just shaping the future of warehouses, but is poised to transform various industries, particularly automotive. Over the next few years, Nvidia plans to integrate its advanced technology into vehicles made by Mercedes and JLR. Additionally, a significant partnership has been formed with BYD, the largest electric vehicle manufacturer in the world, to use Nvidia's new innovation, Thor. This new technology is designed to advance the capabilities of robotic systems and might even lead to the development of humanoid robots, indicating Nvidia's extensive vision in the field of robotics. Project Groot is one of Nvidia's most ambitious initiatives, aimed at significantly advancing humanoid robotics. This project is not just an improvement, but a major advancement in robot capabilities, providing a comprehensive foundational model that processes both multimodal instructions and previous interactions. This foundational model allows humanoid robots to autonomously determine their next actions based on human instructions, effectively bridging the gap between human commands and robotic actions. Central to Project Groot is Isaac Lab, a specialized robot learning application developed by Nvidia. Utilizing the capabilities of Omniverse Isaac Sim for simulations, Isaac Lab acts as a virtual training environment where humanoid robots can refine their abilities and prepare for a variety of real-world scenarios. Isaac Lab is supported by Osmo, Nvidia's new compute orchestration service that efficiently manages workflows across Nvidia's high-powered DGX and OVX systems. This ensures that training and simulation processes are carried out effectively. A remarkable aspect of Project Groot is its learning efficiency. The robots require only a few human demonstrations to learn complex tasks. This impressive capability is enabled by Nvidia's advanced neural networks, which analyze human interactions and translate them into precise instructions for the robots. Furthermore, Project Groot allows humanoid robots to interpret and act on natural language instructions, significantly enhancing their functionality and interaction potential. These robots are capable of performing simple gestures, such as giving high fives, as well as executing more intricate maneuvers, demonstrating a level of intelligence and adaptability that was previously unattainable. Driving these capabilities are the newly developed Jetson Thor robotics chips, specifically designed by Nvidia for optimal performance in humanoid robots. As the field of humanoid robotics continues to evolve, Project Groot stands as a beacon of innovation, leading the charge towards a new era of AI-powered robotics. Nvidia's commitment to developing top-tier software and pioneering technology lays the groundwork for a future where robots are an integral part of our daily lives, revolutionizing industries and altering our interactions with technology. This narrative explores how Nvidia has become a formidable force in the technology sector, continuously pushing the boundaries of what is possible with robotics and AI. The 1990s featured basic TV screens, slow dial-up internet, and simple beige computers. During this decade, the early stages of personal computing emerged. Initially, these computers did little more than display text and basic images, which was sufficient for most users unless you were involved in fields like animation or engineering that required more complex graphics. For those needing better graphics, video game consoles were the preferred choice. However, three engineers from California, Jensen Huang, Chris Malachowski, and Curtis Preem, saw an opportunity to enhance personal computers. They thought of creating a separate chip specifically for managing graphics, which would improve how computers handled visual tasks. From small beginnings to big breakthroughs, Nvidia's early story unfolds. Learn how three engineers' big ideas turned into a company that changed computing. The vision behind Nvidia's first chip. Over numerous meetings at a local Denny's, where they consumed countless cups of coffee, they realized that the central processing units in computers were built for handling one task at a time and struggled with the intensive, repetitive calculations needed for 3D graphics in games. They envisioned a new type of chip that could handle multiple tasks at once, which would be more efficient, especially for tasks that involved complex graphics like those needed in 3D gaming. This idea of a separate chip for parallel processing marked a significant shift in computing technology. This chip, which would later be known as the graphics processing unit, didn't aim to replace the CPU, but to support it by handling graphic-intensive tasks. This development laid the groundwork for the establishment of Nvidia, a company that would play a crucial role in evolving computing and computer science over the next 2 decades. Initially, Nvidia focused primarily on enhancing the gaming experience on personal computers, seeing this as a market filled with potential. In 1993, from a small condominium in Fremont, California, Nvidia began its operation. The company was named Nvidia, combining NV, which stood for next version, and Nvidia, the Latin word for envy. The choice to use green in their logo was symbolic, representing the envy they hoped to invoke with the powerful computing capabilities of their chips. The founders of Nvidia were not just ordinary engineers. Jensen Huang had significant experience in the tech industry. He had previously worked as the director of coreware at LSI Logic and as a microprocessor designer at AMD. His background provided a strong foundation for leading a company that would innovate and push the boundaries of computing technology. Nvidia's innovative approach to computing aimed to make personal computers more capable and versatile, particularly in handling graphic-intensive tasks that were becoming increasingly important in the tech world. The development of the GPU by Nvidia was a game-changer, enabling personal computers to run complex graphics smoothly and more efficiently than ever before. This advancement not only transformed the gaming industry, but also had far-reaching impacts on various fields, requiring sophisticated graphic processing, such as video production, scientific research, and professional design. As Nvidia continued to develop and refine its technology, it became a key player in the tech industry, known for its ability to drive innovation and improve computer performance. The vision and efforts of its founders, particularly in creating a specialized chip for graphics, demonstrated a forward-thinking approach to technology that addressed the growing demands of computer users around the world. This not only helped in shaping the future of computing, but also established Nvidia as a leader in the development of technology that supports high-performance computing and graphic applications. The early days of Nvidia were far from smooth, led by Jensen Huang, along with co-founders Chris Malachowski and Curtis Preem. These founders were well experienced, having worked at major tech companies like HP, Sun Microsystems, and IBM. Yet starting their own business proved to be a daunting task. They quickly realized that real-world challenges in launching a startup were far tougher than any engineering problem they had previously faced. In 1993, Nvidia was at a critical juncture. The founders had a mere $200, and they knew they needed formal business guidance. This situation led Huang to invest his limited funds to officially establish Nvidia, securing a significant ownership stake for himself. This wasn't merely a step to form a company, it was a foundational gamble in a highly competitive industry. Seeking financial support was their next major challenge. Convincing investors required more than just a good idea. It needed a demonstration of potential success or a visionary plan that could appeal to financial backers. The founders faced numerous rejections at first. The tech market was crowded with 89 other hopeful companies aiming to make their mark. Yet Nvidia needed to stand out. Huang's prior association with LSI Logic became crucial here. He used his previous connections to arrange a meeting with Sequoia Capital, a venture firm that had invested in LSI Logic. Initially, they were doubtful, but eventually Sequoia saw potential in Nvidia and decided to invest a substantial $20 million. This funding marked a new chapter for Nvidia. They then embarked on the risky yet innovative path of developing their first product, the NV1, which launched in 1995. The NV1 was distinctive, featuring a quad-based image rendering method, which was unconventional at the time. Sega, a major collaborator and game console giant, disagreed with this approach, preferring the more traditional triangle-based rendering. However, Nvidia persisted with quads, believing it would enhance game rendering by reducing the workload on CPUs. This was crucial during a period when computing power was limited. Nvidia's choice was grounded in a technical strategy. By opting for quadrangles, they aimed to achieve smoother and more efficient rendering of rounded objects in games, an advantage given the technological constraints of the time. The NV1 also facilitated a unique feature. It allowed users to play popular Sega Saturn games directly on their PCs, merging console gaming with PC capabilities. By the time Nvidia went public in 1999, its market value had surged to $600 million, proving that their initial risks and strategic decisions had paid off massively. It's a narrative that reflects not just financial success, but also a series of calculated risks and innovative thinking in the face of industry skepticism. Nvidia's first big failure shows their true spirit of trying new things. This chapter reveals how they overcame setbacks to keep pushing forward. Nvidia's big break with GeForce 256. This story highlights the blend of technical prowess, strategic foresight, and sheer determination that defined Nvidia's early years. The founders not only had to develop groundbreaking technology, but also navigate the complexities of the financial world to secure their place in the tech industry. Their path underscores the challenges tech startups often face, from securing funding and making bold technological choices to handling partnerships and market entry strategies. In retrospect, Nvidia's rise from a small startup to a leading technology company illustrates the payoff of facing early challenges with a strategic and persistent approach. Nvidia's NV1 project, an attempt to integrate a range of functions like 3D graphics, video, and audio processing into one chip, ended up being more complicated than beneficial. The idea was to create a chip that could do it all, much like an octopus that can reach in many directions. But this complexity didn't match what most customers wanted. At that time, the trend in technology was leaning toward simplicity. People preferred a chip that was dedicated solely to 3D graphics, rather than a chip overloaded with multiple features. The NV1 was not only complex but also expensive compared to its rivals, making it a less attractive choice for consumers. The arrival of Microsoft's DirectX, a new tool that helped software developers create graphics more easily, further diminished the NV1's appeal. DirectX favored simpler, triangle-based graphics rendering, which was easier for developers to work with. Nvidia had chosen to use a more outdated method of rendering graphics with quadrangles, which put the NV1 at a disadvantage. As DirectX became more popular, the NV1's limitations became increasingly clear. It lacked support for OpenGL, a crucial graphics tool, and struggled with DirectX because of its outdated quadrangle-based approach. Nvidia tried to fix this by updating the NV1 to work with DirectX through a software solution, but this workaround was flawed. It allowed the NV1 to run DirectX programs, but without the full power of the chip's hardware, which made it inefficient. The practical problems with the NV1 led to significant financial losses. One of Nvidia's main customers, Diamond Multimedia, found the NV1 so unsatisfactory that they returned almost all of the 250,000 units they had bought. This was a huge blow to Nvidia, leading to nearly half of their staff being laid off and a financial loss of about $10 million. At the same time, Nvidia was developing another chip for Sega, called the NV2, which unfortunately was based on the same unsuccessful quadrangle architecture. In a desperate situation, Nvidia's CEO Huang approached Sega's CEO. He asked not only to cancel their contract for the NV2, but also to keep the payment they had already received. Remarkably, Sega's CEO agreed to this request, which provided Nvidia with much-needed financial relief. Without this act of leniency from Sega, Nvidia might have failed completely. This experience with the NV1 taught Nvidia an important lesson about paying close attention to what customers really need and following industry standards. It highlighted the importance of adapting to market demands rather than pushing against them. After moving past the NV1 debacle, Nvidia shifted their focus towards developing products that aligned more closely with market trends and consumer expectations. The failure of the NV1 served as a critical turning point for Nvidia. It made them realize the importance of simplicity and market alignment in product development. This shift in strategy helped Nvidia to eventually become a major player in the PC graphics industry. The company's path from the brink of failure to achieving immense success illustrates the value of resilience and adaptability in the face of adversity. Today, Nvidia's position as a leader in the technology market, with a valuation exceeding $1 trillion, is a testament to their ability to learn from past mistakes and continually evolve to meet the needs of their customers. When Nvidia faced difficulties in the late 90s, their response was not merely to recover. They aggressively re-entered the PC market with a clear plan. The year was 1999, a time when personal computers were becoming a common feature in homes. Nvidia introduced the GeForce 256 graphics card, marking a significant turning point in the industry. This card was notable for being the first programmable graphics card, a pioneering move that introduced the world to the concept of the GPU, or Graphics Processing Unit. This innovation did more than just improve graphics. It fundamentally changed how games could be designed, allowing for much richer visuals with complex shading and lighting effects that greatly enhanced the gaming experience. Nvidia didn't pause to celebrate this achievement. Instead, they used the momentum to go public within the same year, a strategic move that positioned them favorably in the market. By the year 2000, they had negotiated a substantial agreement with Microsoft to develop the graphics hardware for the upcoming Xbox console. This wasn't just any agreement, it was a deal worth $200 million up front, a significant boost compared to their earlier, less profitable engagements with Sega. This deal was a major step up, setting the stage for the launch of the Xbox in 2001. The console featured the NV2A chip, specially designed by Nvidia, marking it as a major player in the gaming industry. Throughout the 2000s, Nvidia's influence expanded well beyond gaming consoles. They became a key hardware provider for major technology companies such as Apple, Dell, and HP, who integrated Nvidia's GPUs into their products. Nvidia seemed to have the golden touch, with each strategic decision and technological advancement contributing to a rapid and seemingly unstoppable growth trajectory. After hard times, Nvidia's smart moves lead to big steps in technology. See how they bounced back with new ideas and became leaders in the tech world. Nvidia's smart strategy with TSMC. But let's take a moment to look beyond the surface gloss of industry acclaim. Among Nvidia's critical strategic decisions was their choice to operate as a fabless chip company. This meant that while Nvidia designed the chips, they did not manufacture them themselves. Instead, they outsourced this task to the Taiwan Semiconductor Manufacturing Company. This arrangement wasn't just a minor detail. It was a significant move towards reducing costs and focusing on what they did best: designing cutting-edge chips. For over 30 years, TSMC has not just manufactured chips for Nvidia, but has been a crucial partner in their success, providing the advanced manufacturing technology necessary for bringing Nvidia's innovative designs to life. Jensen Huang has frequently acknowledged the integral role TSMC has played in Nvidia's success. By outsourcing the manufacturing process, Nvidia could concentrate on design and innovation, allowing them to explore new possibilities beyond traditional gaming and graphics applications. They recognized early on the broader potential of GPUs for parallel processing, which could dramatically accelerate a variety of computational tasks. In 2006, Nvidia unveiled CUDA, a software toolkit that significantly simplified parallel computing. Prior to CUDA, programming GPUs was a complex task, involving intricate and low-level coding that was daunting even for experienced programmers. CUDA streamlined this process, enabling the use of more familiar programming languages like C, C++, and Java to leverage GPU power. This development had a profound impact, extending the use of GPUs far beyond simple graphics applications to fields including medical research, engineering, and more. CUDA was not just a tool. It was a gateway that made advanced computing accessible to a broader range of applications and industries. This was a clear demonstration of Nvidia's strategic vision, allowing them to not only participate in, but actively drive forward the broader tech industry's evolution. In 2008, the Tokyo Institute of Technology made a significant step forward by using CUDA-accelerated GPUs for their supercomputer, demonstrating impressive performance. This wasn't merely a technical achievement. It was a strategic showcase that positioned Nvidia's GPUs as essential tools for a range of industries like cloud computing, machine learning, and video streaming. Major companies like Amazon Web Services, Google Cloud Platform, and Netflix quickly adopted these GPUs, leveraging them for various applications. But the truly transformative moment for Nvidia came in 2012, with a development in artificial intelligence. The key event was the creation of AlexNet, a deep learning neural network designed by Alex Krzyzewski, a PhD student at the University of Toronto. Utilizing two Nvidia GeForce GTX 580 gaming cards, Krzyzewski managed to process an extensive dataset of 1.2 million images, resulting in a significant enhancement in image recognition accuracy, from a 25% error rate down to just 15%. While these numbers might not impress today's standards, at that time, this improvement was revolutionary. It fundamentally changed the perspective on neural networks, a technology that had previously been viewed with considerable doubt, and paved the way for advanced AI tools that we now consider standard, such as ChatGPT, Google Gemini, and Google Lens. The Nvidia GeForce GTX 580 cards were not merely components in this revolution. They were crucial enablers. Specifically optimized for CUDA, they allowed for the efficient implementation of parallel algorithms essential for deep learning tasks, such as those performed by AlexNet. This opened a plethora of possibilities in deep learning applications, and Nvidia was at the forefront of this transformative shift. Their strategic investment in CUDA and the associated software ecosystem began to yield substantial returns. Nvidia's GPUs quickly became the benchmark for training and deploying generative AI and large language models, becoming indispensable tools in the tech industry. After the release of ChatGPT in November 2022, there was a huge jump in demand for Nvidia's A100 series GPUs, as large technology companies competed to buy these advanced processing units. For instance, Microsoft bought an impressive 10,000 units, each costing $110,000. Despite their high price, Nvidia succeeded in selling hundreds of thousands of these GPUs, significantly boosting their sales numbers. By the end of July 2023, Nvidia's sales had skyrocketed to a remarkable $13.5 billion. marking a 101% increase compared to the same period the previous year. On May 25th of that year, Nvidia's stock market value dramatically increased to $184 billion in just one day. Shortly thereafter, on May 30th, 2023, Nvidia reached a significant achievement by becoming the sixth company worldwide to achieve a market capitalization of $1 trillion, and today, their market cap exceeds $2 trillion. This situation isn't just a tale of technological progress and economic gains. It vividly shows how well Nvidia positioned itself in the market and chose the right timing. By syncing their technological innovations with what the market needed and was ready for, Nvidia didn't just join the industry trends, they actively shaped the future of the industry. Their capability to transform technological breakthroughs into massive financial success demonstrates a deep understanding of market trends and consumer demands. Nvidia's progression from a company that played a strategic role to a dominant leader in the global tech market illustrates the power of combining technological innovation with smart business strategies, leading to extraordinary success and leadership in the industry. This story highlights Nvidia's ability to not just keep up with market trends, but to forge and lead them, drastically changing both the technology landscape and their own company's destiny. Through strategic movements and innovative developments, Nvidia has shown an exceptional ability to foresee and dictate market directions, securing a pivotal position in the tech world. Their path is a powerful example of how strategic foresight, when paired with innovation, can transform a company into a powerhouse, leading to not just success, but dominance in the marketplace. This narrative of Nvidia's ascent underlines their pivotal role in defining technological standards and shows how strategic market positioning can elevate a company to the highest ranks of the global economic arena. Does Nvidia's new AI chip truly defy the laws of physics? Or is there a hidden agenda behind this incredible breakthrough? What do you think about the future implications of this technology? Share your thoughts in the comments and let us know if you believe this is the next big leap or just another tech hype. Don't forget to like and subscribe for more.